Welcome everybody to your video lesson for Unit 2.4. Today we're talking about building functions from function operations and finding their domains. So a review, operations with functions just means using function notation. Okay, so f plus g of x really means f of x plus g of x. And the same thing goes for the difference, the product, and the quotient. Now the thing we have to remember for quotient is that g of x cannot equal 0 because then we know that makes our entire expression undefined. Okay, so one thing that we have to keep in mind is we need to know how to find the domain of many different types of functions very quickly today in order to then find the domain of the result, okay, from these function operations. Okay, so when we are talking about the creating the domain here for the result, we have to take into account the domain from both of our original functions. Okay, so everything has to be accounted for. So you're essentially going with what is the most specific from the two originals and then making sure that it applies to your result, whether it's the product, the difference. Okay, so a very simple example here. F of x is 2x minus 1. That's a linear function, so that has a domain of negative infinity to infinity. Okay, g of x is a square root of x, which means that you'd have to limit your domain to just be positive numbers, which is how we get 0 to infinity for the domain of that. So let's say that we were adding these two functions together. Well, we now need to take into account both of them. Okay, so the domain for f plus g of x now together would have to take on all of the restrictions from whatever is the most specific, which would be 0 to infinity. Okay, so we could no longer include those negative numbers from the domain of f because they don't apply to the domain of g. So let's take a look at some examples. Okay, so I have f of x, which is x squared. That's a parabola. So parabolas always have a domain of negative infinity to infinity. And g is a square root. So we know we got this by restricting our domain to only positives. Okay, so if I want to do f minus g of x, that means f of x minus g of x. Okay, so this is actually my new function. There's not really anything I could simplify there. Okay, and my domain now has to take into account the restrictions from both. So I have to take the most specific from my two original functions, and then I have to make sure that there aren't any additional restrictions that came up through the designated operation. Okay, so the domain for this would now be -1 to infinity, okay, because that takes into account the most specific aspects from the two original, and nothing came into account, or nothing additional came into play when I subtracted the two functions. Really, the only time you get something additional would be with division, okay, which we're going to look at right now. So f divided by g. So that means x squared divided by the square root of x plus 1. Okay, so we know that the numerator, x squared, that's giving us negative infinity to infinity, and the bottom, that is already restricting us. But now that this is in the denominator, this can't even be equal to 0 anymore. This has to strictly be greater than, otherwise this becomes undefined. So now how is this changing my domain? So not only am I taking the most specific aspects from the two originals, I now have to tailor it to my new function after the performed operation. So this is actually -1 to infinity now. So it's even more specific than the two originals. Okay. F of x is what kind of function and what is its domain? Okay, we should know that from the x squared, that means it's a quadratic, and it always has a domain of negative infinity to infinity. G of x, hopefully that's very clear that that's linear, and that also has a domain of negative infinity to infinity. Okay, so f plus g of x means x squared minus 1 plus x minus 1. So here is my new function. Okay, neither function came with a restriction. Okay, and adding the two functions together is not going to introduce any additional restrictions. So the domain here can remain negative infinity to infinity, also because this resulting function is also a quadratic. Okay, and now we're going to multiply. So that means x squared minus 1 times x minus 1. Hopefully we remember that this needs to be FOILed. And actually there's nothing to combine here. Okay, so that is my final function. This is a cubic. Okay, I can tell by the third power. And if you remember from your 12 basic functions, this should also have the domain of negative infinity to infinity. Okay, and since neither of the originals came with a restriction, that applies to this as well. Okay, hopefully we're finding this to not be too terribly difficult, and it really helps if you know your 12 basic functions. Okay, so again, f is a quadratic and g is a linear. Okay, we're actually just going to focus on the division for this one. Okay, so that means x squared minus x minus 6 divided by x plus 2. So I do need to factor and see if there's anything that will cancel here. Now, my result looks like it's linear. Okay, and that's true that it is. But in getting there, okay, I had to cancel. And when I canceled, this created a hole. Okay, and we know that a hole produces a restriction in my domain. So even though the two originals came with 0 restrictions, and my result looks to be linear, which theoretically shouldn't have any restrictions, in getting there, I did create a problem in my domain. So there's a hole at x equals -2, and that's going to have to be accounted for in my domain. So this domain is actually going to become more specific than the two originals. Okay, so that is how we find the domain after we perform function operations. So you are really just looking at the two originals and trying to determine which is the more specific. Okay, and then sometimes when you are dividing, the division creates an additional restriction that you need to incorporate into your new domain. Okay, so please make sure that your notes are complete. If you have any questions, write those down, and I will see you next time. Thanks for watching.